It's easy to transform variables with the transformC function. There are two required arguments, type and x. The type argument specifies the type of variable transformation you want to execute. The function supports many different types of variable transformations. I will demonstrate some of them in this video and show you where to find a complete list of transformation types. The x argument is set equal to the variable to be transformed. With transformC, you have the standard option to specify the dataset name. The function also has some unique optional arguments. I will show you how to use optional arguments named response, cutpoints, groups, and confirm in this video. The transformC function doesn't create a new variable automatically. To create a new variable, you assign the function's output to a new object or add the function's output to an existing dataset. To see how to use the transformC function, let's work through some examples together. Okay, so I'm making this video to show you how to use the transformC function in the RCP3A package. It's a very useful function that you can use to transform variables from one level of measurement or one style of coding to another level of measurement and style of coding. All I've done before the video started was to run the library command to load the RCPA3 package. So to use the transformC function, you can type its name in, followed by the parentheses, and there are two required arguments. I'm going to go to the documentation page so we can see this on the screen as we work through it. Two required arguments are type and x. Type is the type of variable transformation, and x is the variable that you want transformed. So I'll just illustrate, I think, guess what the first one on the list? So center. So the type of transformation would be the center, and we are going to center, let's do one from the states data set. That'll be a little cleaner. So let's center, I'll just start with the abortion rate. So the function is calling us for center abortion rate. I'll put these arguments in this order so you sort of read what's happening here. Like, what are we doing? We are centering, we are transforming a variable by centering abortion rate. Let's run this and see what happens. It gives us a little confirmation warning, a heads up that make sure you're not about to overwrite the state's abortion rate variable and lose data. You can use the confirm equals f argument to bypass this message. Do you wish to continue? Enter y to continue or any other key to cancel. So I will be brave and continue here. And then what it has done, it has returned the mean centered abortion rate in the states. So it is now reporting from the first state to the 50th state the difference between their observed abortion rate and the mean abortion rate in all the states. I think this might be helpful. I'm going to just show you what the raw variable looks like. Probably should have started with this, but the raw variable itself is the number of abortions per 1,000 women, and you can see the numbers here. And the mean centered value, it takes the mean of this set of the raw data and subtracts that from the observed value. So some of the states are higher than the mean and other states are lower than the mean, and that can be an interesting value to work with. So this is the most basic use of the transformC function, and the type can be adjusted to use other variable transformations. Some of these get a little more complicated and require additional optional arguments, but I can show you some of these pretty quickly. So like ln stands for the natural log. It's the mathematical transformation. It gives us our same confirmation. It just logged the abortion rate in the states and is returning the logged values. You can do a log 10. You can imagine what that looks like. Percentile rank, rank, whole, and Z. Z is kind of an interesting one. Z means just kind of a notation for a standardized version of a variable. And it's similar to mean centering, except for it would divide the difference from the mean by the standard deviation. So it would say that the first state is 0.429 standard deviations less than the mean. And that can be a useful transformation in some applications where you're not particularly interested in the units of measurement, like the number of abortions per 1,000, but are more interested in how a standard amount of variation affects some results or is explained by some result. This measurement now, the standardized scale, is really like unit independent. It wouldn't have mattered if we had measured the abortion rate, per 100 women or 1,000 women or per million women. The standardized value would be the same in all those instances, which is the virtue of standardizing a variable. So a variety of different things you can do with the transformC variable with the different types, and I'm not done yet. So if you stick around, I will show you some of the optional arguments for some more things you can do with the transformC that make it a very useful function.